Okay, everybody. So in this video here, we're going to take another look at common factoring. So we're going to factor this x squared plus 6 plus 3 to the negative 1. Okay, so when I take a quick look at this, I'm not seeing a lot that's kind of explicitly common to all three of these terms here. However, it's that x to the negative 1 that draws my attention here, because one of the things that I can do here when I look at this is I can see this as x squared plus 6 times x to the 0 plus 3 times x to the negative 1. Now, x to the 0 is just going to be 1, okay, for almost every value of x there. So in this particular case, like, why would I do that? Why would I write that down? Well, because the rule is I want to factor out the factor that has got the smallest exponent, okay? And so granted, I can rewrite that 1 as x to the 0, but even then, that is not going to be the smallest exponent on x in this expression here. It's actually going to be x to the negative 1. And so that is actually what I'm going to factor out here. And so now I'm going to go term by term, and I'm going to factor out the x to the negative 1 here. So in that first term, I get x squared divided by x to the negative 1. And that is going to be x to the 2 minus negative 1. And this is where a lot of people struggle with this. Because when I do that division, I'm subtracting the exponent, which in this case is negative. And so this is going to get us x cubed. In that second term, I've got 6x to the 0 over x to the negative 1. That is going to be 6x to the 0 minus negative 1. And again, that's just going to become addition. So 6x to the 1. So 6x. And then in my last case here, I've pulled out the x to the negative 1, so it's just going to be 3 left over. Now, at this point here, normally we would ask people to take a look at that, what we've just been left with there, and see, can that be factored any further? And for the purposes of this particular course here, really what we're asking for is it a quadratic that you can take any further? In this case, it isn't, so we're going to stop it right there.